Hi, today we're looking at section 7-4, division properties of exponents. Remember to take notes. You can pause the video at any time to write your notes or to go back and review, and complete the check it out problems after each of the examples. Our learning target today is I can use division properties of exponents to evaluate and simplify expressions. In our last lesson we did multiplication properties of exponents. So quotient is division. A quotient of powers of the same base can be found by writing the powers in a factored form. So we have 3 to the 5th over 3 cubed. They have a common base of 3, and we can now subtract the exponent. So 5 minus 3, or 3 squared, which should be 9. Let's look at that property. The quotient of powers property states the quotient of two non-zero powers of the same base equals the base raised to the difference, or subtracting the exponent. So 6 to the 7th over 6 to the 4th, the base is 6. So we keep the base the same, but we subtract 7 minus 4, which would give us 6 cubed. Like in our last example, we had 3 squared. So let's go ahead and simplify these expressions. So here our base is 2. Then we quotient, so we have subtract 7 minus 2, which would be 2 to the 5th. Here our base is x for the second example. So x to the 4 minus 3, or x to the 1, or you can just have x. For c, we've got quite a bit going on here. So let's take one thing at a time. Let's go d to the 4th, e cubed over d squared, e squared. So now we're not simplified yet because we have the same base repeated there. We have d repeated twice, and we also have e repeated. So let's simplify this even further. So we're going to get d to the 4 minus 2 times e to the 3 minus 2, or d squared e. And for our last example, again, let's draw out and see where we're going to be going. We have 3 to the 1st over 3 squared, so we're going to end up with 1 3 in the denominator, and that other 3 is going to go to 1. 4 cubed over 4 to the 4th, we're going to get a 4 in the denominator and a 1 up here. And 5, we have 5 5s on top, 5 3s on the bottom, or 3 5s on the bottom, so we're going to end up with 5 squared on top. So we can get 25 over 12, because we just multiply as we would on those other cases there. You can also, for d, if you're thinking about it, we could do 3 to the 1 minus 2 times 4 to the 3 minus 4 times 5 to the 5 minus 3, which gives us 3 to the negative 1 times 4 to the negative 1 times 5 squared. And then we go from here to that step. So either way, it's the same thing. You're subtracting the exponents. Here are your 4 check-it-outs. Good luck. Bring the questions to class. Now we're going to be in scientific notation. Again, the nice thing with scientific notation is it's just exponents. The bases are the same. Base 10 raised to an exponent. So you want to simplify and write the answer in our scientific notation. This example takes into account both our division properties of exponents and multiplication properties of exponents. So we have 3 times 10 to the 10th divided by 6 times 10 to the 6th. Let's write that as a fraction. So 3 times 10 to the 10th over 6 times 10 to the 6th. We can bring this coefficient part out, 3 over 6, and then times 10 to the 10th over 10 to the 6th. 3 over 6 is 0.5. 10 to the 10th over 10 to the 6th is 10 to the 4th, because 10 minus 6 is 4. Taking 0.5 and writing that in scientific notation becomes 5 times 10 to the negative 1. And we carry this 10 to the 4th down. So 5 times 10 to the negative 1 plus 4, bases are the same. We add the exponents, gives us 5 times 10 cubed. So here's your example, your check it out. Again, write those as a fraction instead of having that division symbol. They do as a fraction. In this example, the Colorado Department of Education spent about $4.408 times 10 to the $9 in fiscal year 0405 on public schools. There are about 7.6 times 10 to the 5th students enrolled in public school. What was the average spending per student? And again, write your answer in standard form. So to find the average, we're going to take total spending divided by the total number of students. So we spent $4.408 times 10 to the $9. That goes in the numerator. And we had 7.6 times 10 to the 5th students. That goes in our denominator. So we can split up, put the coefficient in the front part of your scientific notation term out front, so 4.408 divided by 7.6 times 10 to the 9th over 10 to the 5th. So we end up with 0.58 times 10 to the 4th, because 9 minus 5 is 10 to the 4th. They want it in standard form, so it's going to be, you're going to be spending $5,800 per student. It's the average spending. Here is your example. And again, write your answer in standard form. So now we're looking at the power of a quotient. And that can be found by first writing the numerator and denominator as powers. So 2 thirds cubed would be 2 cubed over 3 cubed. And let's see what that's going to look like. So positive powers of a quotient. The quotient raised to a positive power equals the quotient of each base raised to that power. So 3/5 to the 4th would be 3/5 times 3/5 times 3/5 times 3/5, or 3 to the 4th over 5 to the 4th. So here's an example. We want to simplify these three expressions. The first one, we have 4 over 7 squared. So that's going to become 4 squared over 7 squared, or 16 over 49. Our next example, we're going to get 3 to the 4th, d to, we have to multiply those, d to the 8th over e to the 4th, f to the 4th. We know 3 to the 4th is 81, d to the 8 over e to the 4th, f to the 4th. And our last example, again, we have to multiply, and remember there is this implied 1 exponent there, so we get 2 squared x to the 6th over x cubed y cubed. We can simplify 2 squared, gives us 4. We have x to the, we have two bases are the same. We have a base x and a base x there. So with that, we subtract 6 minus 3 all over y cubed, which is going to give us 4x cubed over y cubed. So with these, oh, I'm sorry, let's actually redo the last one. So let's revisit the last example. This one, do what's in for the order of operations. So let's take care of what's inside here first. So 2x cubed over, distribute the exponent to each term there, x cubed, y cubed. It's all still raised to the second power. So now we know we have an x cubed on top in the numerator, x cubed in the denominator. Those will simplify to just be 1, leaving us with 2x squared y cubed times 2, distribute the exponent, giving us 4 over y to the 6th. So when you can simplify within, always do that first and work your way out order of operations. Here are your 3 check it outs. Good luck. So remember that x to the negative n is the same as doing 1 over x to the n. Just put it over 1. If x is a fraction, this would be the same as saying it's going to equal 1 over a to the b. Actually, let's not do it that way. We're dividing by a fraction, same as multiplying 1 times b over a. So we can take the power exponent distributed here, and so dividing by ab to the n, we can multiply by b to the n, a to the n, which would be same as b over a to the n power. So that's a negative power of a quotient property. when you have a negative exponent. The quotient raised to a negative power equals a reciprocal of the quotient raised to the opposite, or the positive power, because it's going to change location. So it's 2/3 to the negative 4, same as saying 3/2 to the positive 4. And you go from there. So let's simplify these three. We have 3/4 to the negative 3. That would be the same as 4/3 raised to the third power, which would be 64/27. So you have a negative exponent, so you have to put it over 1 or take the reciprocal. Our second example, we have 2x squared over y cubed. So that's going to be, we can flip it, it's going to be y cubed over 2x squared all to the positive 2, or y to the 6 over 4x to the 4th. And our last example, we have 2/3 to the negative 2 times 6m over 2n all to the negative 3. So let's take one term at a time and simplify as we go. So 2/3 to the negative 2 is 3/2 squared times 2 to the n over 6 to the m cubed. So for our last example, distribute the exponent to everything. So we get 3 squared, and we can multiply, so we can do everything in the numerator, times 2 cubed n cubed over 2 squared, 6 cubed m cubed. 3 squared is 9. We have 3 2's in the numerator, 2 in the bottom, leaving just 2 on top, n cubed. And then 6 cubed is 216 m cubed. 9 times 2 is 18 divided by 216. So we end up with n cubed over 12 m cubed. Here are your 3 check it out problems. Bring any questions you have to class. So to summarize this division of properties of exponents, keep in mind when factors in the numerator or denominator divide out, replace them with a 1. And quotient means division, something over something. Of powers means, in this case, we could have x cubed over x squared. We're talking powers here. A power would be a base raised to an exponent there. Of a quotient, in this case, quotient's division, so x divided by y, all raised to the third power. So these are just some examples and different words we use to talk about it. Bring any questions you have to class, and good luck.